the total area under a curve, a normal curve, is always equal to 1. So if we can recall from our textbook where we have the z-chart, those values all measure between 0 and 1. So probability and area are both measured between 0 and 1. However, if we're talking in terms of percentage, percentage is measured between 0 and 100%, which is obtained by multiplying area by 100. So this is true. The probability that a random variable will be within 2 standard deviations of its mean is approximately 0.68. So if we were to draw a bell curve, given that the mean is in the middle, 1 standard deviation below to 1 standard deviation above measures 68% or 0.68 probability, and 2 standard deviations below and 2 above will measure, so 2 standard deviations is 0.95 probability or 95%. So 2 is false. The notation of z with n and in parentheses 0, 1 means that z, the random variable z, is normally distributed with a mean of 0 and standard deviation of 1. So this is true. Finding the probability that a standard normal random variable has a value greater than negative 1.65. So this is just simply saying find the probability that z is greater than negative 1.56. Okay, do this in our calculators or by using our textbook, the table in our textbook, but we're going to use our calculators. We're going to second vars 2 for normal CDF, and we want it to be greater than this value. So our lower limit is negative 1.56, and our upper, since we're unaware of it, will be positive 1 E99, which represents positive infinity. We get the E by pressing second and then comma. Since it is a z-score, I shall leave my mean as 0 and my standard deviation is 1. Let's enter 3 times. Round it to the nearest 10,000. I see that my answer is C. Five appears to be tricky, but this is only because it has a lot of words, but not quite so much. So what I like to do for these problems is skip directly to the end and to highlight or underline or point out what it is that the question is asking. So it's asking, what is the probability that you make at least $2 on each share, and to do the same thing for stock B. It's important to note that we're looking at a value that is increased by $2. So if I'm looking at stock A, which has a mean of 25 and a standard deviation of 3. So if I wanted to make $2 on that 25, that would be the probability that X is greater than 27. And I also bought stock B for 25, but this has a different standard deviation of 5. Alright, so for stock A, I can go back to my calculator, and I want X to be greater than 27. So normal CDF, my lower is 27, positive infinity, and since I changed my lower to an X value, I must also change my mean from 0 to the stated mean of 25. Standard deviation goes from 1 to now 3. So the probability that you'll make at least $2 on stock A, rounded to the nearest 10,000, is approximately 0.2525. Since that is not available in any of my answer choices, I know to choose none of the above, and I don't even have to find the probability of stock B. Marks on the chemistry test are normally distributed with a mean of 65 and a standard deviation of 12. They want to know what percentage of students have scores below. So this time we want to find the probability that X is below 50. Back to the calculator, normal CDF. So if it's below 50 and I do not have my lower limit, I'll go with negative infinity. Below 50, so that means my upper is 50. 50 is an X value, so I'm changing my mean to 65. And my standard deviation to 12. I have an error. Go back. What did I do wrong? Negative 1E99. Okay. And since it says percentage and I'm given a probability, simply multiply by 100. And if rounded to the nearest whole number, this becomes 11%, which is A. Question 7 uses the same information as question 6. And we want to know the approximate 90th percentile of the mark distribution. we have to first recall that percentiles represents the percent of data below a certain value. So if we're in the 90th percentile, this is saying that the area to the left is 0.90. If I were to draw this in the bell curve, the mean represents the 50th percentile, so 90th percentile, not sure of the value. Means that everything to the left would be 90%. And because I have my area, I can go to inverse norm. Once again, my area is 0.9. I need the x value, so I'm going to use my mean of 65, standard deviation of 12. Round to the nearest whole number, this becomes 80, which is A. Question 8, one of my favorites. Not because it's difficult, but because it's actually really easy. Once again, we have to concentrate on the necessary information. This question presents us with quite a bit, so I skip to the end to look at what the question is asking. So skipping to the end, we see that it's telling us that the bounds for, we want to know the bounds for the grade of B, and we want to also know the percent of students who received a B. So we're pretty much only focusing on a grade of B. As I'm going through the problem, I see that they're giving me information for C, C+, and then here I see that I'm finally given information regarding a grade of B. Working with any other normal distribution problem, I'm going to try to see if they give me any other pertinent information, such as the mean, which they do, 60, and a standard deviation of 12. So students who, on a normal, a standardized test, who got a B, score between what two values is what they're asking, and what percentage of students is that. This could be done one of two ways. So we can first start off going back to normal distribution, normal CDF, and the 1 and the 1.5 that they give us, our Z values are also standardized values, so I can type in as my lower 1.0 and as my upper 1.5. Since these are Z scores, I can leave my mean, and I get what appears to be area or probability multiplied by 100 to get the percentage. And the closest percentage here is C. Now, how did they get these values? It says between 1 standard deviation and 1.5 standard deviations above the mean. If I have a mean of 60 plus 1 standard deviation above it, so standard deviation is 10, but only 1 above, that gives me a 70. 60 plus 1.5 standard deviations is 75. Because 65 is only half a standard deviation above 60, so we could have eliminated those immediately. Final answer is C. Once again, looking for important information above all things else. Mean, 12.3 minutes. Standard deviation, 0.4 minutes. And what are they asking us? The probability that the skier's time will be between two values. So this time they actually gave us two values. So 12.1 represents our lower, and 12.5 represents our upper. Going back to normal CDF, substituting in 12.1 and 12.5 as our upper and lower. I must also change my mean and standard deviation, as these are x values, 12.3 and 0.4. As for probability, so I do not have to multiply by 100. Closest value, 2.3829 is 3830. Remembering that we can also get a different value if we use the textbook instead of the calculator. Answer number 9 is B. Always first, point out important information. Mean of 175 centimeters. Standard deviation of 6 centimeters. 20th percentile. So previous question we learned that percentile, we can recall that percentile means the percent of data below. So this means the lowest 20% or an area of 0.20. I know to use inverse norm in my calculator. Area 0.2 or 0.20. Changing my mean to 175 and my standard deviation to 6. Rounding to the nearest whole number, this becomes 170, which is C. Number 11, another question with quite a few words. By this time we should be learning to point out the key information. A mean, 2.2 days, standard deviation of 0.4 days, and what they want us to find out is we would expect 90% to die within how many days. So once again, 90%, this is the lowest 90%. An area of 0.9. If I were to draw a curve estimating this, and I know that my mean is 2.2, and we don't know this value yet, so we'll call it x. It is the x value. And 90% of all lice should die within up until this point, and the highest 10% will live past this point. So, inverse norm, 0.9, mean of 2.2 days, standard deviation of 0.4 days, rounded to the nearest 10th, which makes sense, as all the answer choices do, because I'm expecting a value at least above 2.2. Correct answer is D. We have a mean of 15 and a standard deviation of 10. And we're asking to find a probability that would have a negative value. So if we recall the number line and 0 is the middle, numbers above 0 are positive, but numbers below 0 are negative. So the observed value that we're really trying to focus on here is 0. So we're going to normal CDF, and we want to see what is the probability that X is less than 0. My lower, since it's less than, we'll leave it as negative infinity, and my upper should be 0. 0 is the X value, so I'm changing my mean to 15 and standard deviation of 10. Probability, so I don't have to multiply. Right to the nearest 10,000. 12 is A. So we're speaking about characteristics or normal distribution. So when we're discussing normal distribution, if we were to draw a picture of it, we would draw a bell-shaped curve, and in the center of this bell-shaped curve, we would draw a mean, and the mean represents 50th percentile, so 50% of my data lies below this value and 50% above. This is the metric about the mean. As discussed in question 1, the entire area underneath the curve is always equal to 1, or a percentage of 100. And the probability that X is equal to any one specific value is 0, because the mean is equal to 0, and standard deviations are equal to 1. Only thing unfamiliar here is discrete distribution. The reason why we have not discussed it in this chapter is because it is not a characteristic of normal distribution. So for number 13, should have chosen D, which is an unfamiliar concept to us for now. Finally, number 14. Mean of 100, standard deviation of 10. And now they want us to find the area equal to 0.95 or 95%. So between what two values is 95% of the data? If I draw a bell curve with 100 as my mean, positive 1 standard deviation of 110, positive 2 standard deviations of 120, Positive 3 standard deviations of 130. Negative 1 standard deviations, 90. Negative 2 is 80. Negative 3 is 70. If we recall the 68, 95, 99.7 rule, between 90 and 100 is 68% of my data. So we want to find where is 95% of my data, or 0.95 probability. So 90 to 110 is only 68. Between 80 and 120 is 95. We have numbers close to those, but not exactly. So we'll come back to that. Between 98 and 101.96 or 102. So I would estimate 98 to be about here and about 102 to be here. So we see it's inside of the 68. So if it's inside of the 68, it means it's less than 68, meaning it can't possibly be 95%. And between 70 and 130, which is already outside of 95, even if we couldn't remember the exact number, it's much larger than 95. It's 99.7%. So now we can choose between none of the above or B. So B does not give me the exact values I'm looking for with 80 or 120, but 80 is 0.4 above 80, and 119.6 is 0.4 below 120. So I can check this in my calculator, and given that I'm given two values, they're my lower and my upper. So for my lower, to check the values, I have 80.4 and 119.6. These are X values, so I change my mean, 100, and then 10. And the area between, well, the probability between these two, that a value will be between these two values, is 0.95, which is what I was looking for. So the answer is B.